Hey guys, welcome back to the channel. In this video, we're going to be looking at counting and the binomial expansion, which is chapter number 10. Let's begin with the product rule. You read the question in front of you and then we'll discuss the question and the answer. So it goes like this. Suppose there are 3 bridges in front of you. After crossing one of them, you encounter 4 more bridges. What is the total number of ways in which you can go from point A, which is the starting point, to point B, the end point? So think about this for a few minutes. I will draw the diagram. Let this be A. This will be M. And this will be B. So what is the total number of ways in which you can go from here to here? Okay, if you have the answer, then we'll discuss. I mean, it's given here, but I'll explain why that is. So from here to here, you can go in 3 ways, right? The first path, second, and the third path. So there are 3 ways to go from A to M. So this is 3. And from M to B, there are 4 possibilities. Because you can take this route, this, or this. So there are 4. And now if you want to go from A to B, you'll have to multiply them. So that's the reasoning. So if you go from A to M, there are 3. M to B, it's 4. So in total, it's going to be 3 into 4. We can like label all of them. So let's. The possibilities are 1A, 1B, 1C, 1D, 2A, 2B, 2C, 2D, 3A, 3B, 3C, and 3D. If you count this up, you're going to get 12 ways. So that's what is written here. If there are m different ways of performing an operation, and for each of these there are n different ways of performing the second independent operation, this is extremely important. The reason why is because imagine if you took route A, you will go to a different bridge. Then the events are not independent. And so therefore, it has to be an independent operation. Then there are mn different ways of performing 2 operations in succession. Also, it has to be in succession, one after the other. So that's the principle. If you do m different operations, and then after which you perform n independent operations, then the different number of ways of performing the operations is m into n. So that's the logic, or that's the statement. Okay, and the product rule can be extended to 3 or more successive independent operations. Okay, imagine from here you have 2 more paths. Then what would be the answer? Think about it. Okay, so it's going to be 12 into 2. This is going to be our answer, which is 24. If this is clear, then let's move on to the questions. Take a couple of minutes to answer these. Let's look at the first question. A table tennis competition has 7 teams. In how many different ways can the top 2 positions be filled in order for premiership points obtained? Let's put this as the first place and the second place. The first place can be filled by 7 teams. So any one of these 7 teams can win, right? So that's why we put 7 in the first place. Okay, imagine team, I don't know, C has won. Team C cannot win the first and second place, right? So therefore, we're gonna have six possibilities for the second place. So what we need to do right now is multiply them because of the product rule, and now we're gonna get 42. So that's the answer. Because the first position can be filled by 7 teams, but for the second one, it can only be filled by 6 teams. Because a team cannot cannot fill the first and the second position. And now let's look at the second one. How many 3-digit numbers can be formed using the following digits? Okay, let's draw this. This is the hundreds place, tens place, and the units place. So if we can use any of these 5 numbers as often as we desire, then the first place can be filled in 5 ways because, well, we have 5 numbers available. So this can be filled in 5 ways. Even the second one can be filled in 5. Even this. Now we have to multiply them because they're in succession and they're independent events. So it's going to be 125. That's the answer. And at most once each. That means they cannot be used 2 times or 3 times. So the first place can obviously be filled in 5 ways. Now let's look at the second one. Imagine 2, we had the digit 2 in the first place. Then we can't use this again. So we cancel this out and we use the remaining 4 digits to fill the second place. So this is going to be 4. And now just imagine that the number was 3. We cancel it out. And now there are 3 available digits. So 3. Now we multiply them because of the product rule. This is going to be 20 into 3, which is 60. This can be done in 60 ways. Let's look at the last question. A football competition is organized between 8 teams. In how many ways can the top 4 places be filled? This is very similar to the first question. We do 8 into 7 into 6 into 5. The logic remains the same. So this is going to be 1, 6, 8, 0. So that's the answer. I hope this topic is clear because this is going to be really important. And also your logical reasoning is important in this chapter because you're going to have to think logically about like the real life scenarios in order to answer these questions. So for example, the first one. Imagine you did not know that a team could not win the first and second place. We all know this. This is common knowledge. But if you didn't, then you would have done 7 into 7, which would have been 49. But that's not the case. So therefore, you should be thinking a lot in this chapter. Let's move on to the counting parts. This is very similar to the product rule. But in this one, we're going to look at different possibilities. So I really like this example, so I'm going to explain this. So we have to consider the road system illustrated, which shows the roads from P to Q. This is P, this is Q. From A to Q, there are 2 paths. A to Q, there are 2 paths, 1 and 2. And from B to Q, this is the counting principle, the product rule. So this is going to be 3 into 2, which is 6. So 6 ways. And then from C to Q, there are 3 paths, 1, 2, 3. This is going to be 3, 6, and 2. And so therefore, from going from P to Q, there are 11 paths. We have to add them. In this case, we're adding them because of the word or. We can choose this path or this or this. And therefore, we add the numbers. If it's and, then we have to multiply. If it's or, we have to add. Now let's look at a few examples. These are very similar to this one. So let's label this as A. To go from A to Q, we can either cross this path, and so on. So this can be done in 4 into 2 equals to 8 ways, or we can go from P to Q this way. This is going to be 3, 2, and 2, and we multiply them. It's going to be 6 into 2, which is 12. So therefore, total would be 8 plus 12, 20. Let's do the same for this one. This is 2, 4 into 2, 8, 3 into 3, 9. Therefore, 19 ways.